हेलो हेलो हेलो। और भाई कैसा? तो चलिए सॉल्व करते हैं आज वाला लीट कोड क्वेश्चन। ये है 486, राइट? प्रेडिक्ट द विनर। ओके, गेम थ्योरी क्वेश्चंस। हाँ, लेट्स सी व्हाट द क्वेश्चन says. We have given an integer in nums. Okay, we have two players, one and two. Initially start with zero. Okay, and they can take from either ends, right? Pick from ends. Okay, okay. Return true if player one can win the game. Okay. We have to return true if player one can win the game. And both plays optimally. See, this line is very important. Okay. Constraints are nums is right, very small 20. This is 10 raised to power 7. Okay. So you see this nums dot length, right? It's 20. It's very small. Now, see, this is the standard game theory question. Okay. Game theory basically means, right, both plays optimally. Okay. Both plays optimally. Okay, I think my handwriting is not good. Okay, both plays optimally you want, right? Either you want to make some player win. Okay, make a player win. Okay. So what happens in this case, right? We have given an array, right? Let's say this is an array. Okay. So we'll take this example. Okay, 152. No. Let's say this is 1, this is 5, this is 2. See, both the players, right? 1 and 2, they both want to play optimally. Optimally means what happens? Both want to win, right? See, if it's player 1 turn, right? Player 1 turn, right? He wants to win, right? If player two's turn, he also wants to win, right? See, he also wants to win, or can I say he want, right, A to lose, right? मतलब B नहीं चाहता कि A जीते, मतलब player one जीते basically ये है. Okay, so and what is their score? Pick from end. Okay, pick from end and add it to score. Okay, now let's see this example, right? Let's first try to understand why picking the maximum from end, why it will not work, right? Why picking maximum from end, okay, will not work. This is important, right? You see this, if you understand this question, right, then you will get the approach to solve this, right, our problem. Okay, so let's see this, right? Let's take this example, right? Second one, this one, 1 5 2 3 3 7. So this first one is very simple, right? So we cannot take this example properly. 1 5 2 3 3 7. Okay, let's say this is my example, right? Then now first is player one turn, right? Okay, see, if he picks this maximum, right? Now what is left with? 1 5 2 3 3. Okay, now player 2, what he will pick? This maximum, right? 1 का score is 7, 2 का score is 0, 1 का score is 7, 2 का score is what? 2 3 3. Now again player 1 turn, right? He will pick whatever is left among this, right? 5. Now step right, 2 will pick 1. See, and what is the score right here? 1 is 7 plus 5, 2 is 2 3 3. 1 is what? 7 plus 5, 2 is what? 2 3 3 plus 1. But tell me, so if both start picking, right, maximum from the end, right? So this player 2 can win, right? Player 2 win. But this is important. See, what if player 1 in their first turn he chooses a 1, right? If he chooses a 1, then player 2 only have either 5 or 7, right? See, so let me write it in this side, right? 1 5 2 3 3 7, right? So if player 1 chooses 1, right, then player 2, right, he either choose to force 5 or 7. Okay, so whatever he chooses, let's say he chooses 5, then player 2 can choose, 1 can choose 2 3 3, right? He chooses 7, right? Player 1, can the player 1 wins, right? Now if I want to answer this question, why picking maximum will not work? Why? See, because, right, choosing a number, also affect future decision. Why? See, because if I choose a smaller number now, I can make the second player forcefully choose a number that can give me a outcome which is in my favor, right? I can make player to choose one from 5 or 7 so that I can choose this bigger number 223, right? So see, that's why, because right, this current state, let's say this is current state, right? This is current state and this is future state, right? So this depends basically, right? There is a dependency on them. That's why we cannot simply choose the maximum from the ends, right? Okay. So if this thing is important to understand, right? I'll also add it to the example. Okay. Okay. So now we have seen, right? So what now? Right? How we are going to solve this? See, at every step, right? Both want to maximize their score, right? Both want to maximize their score, right? So let's say at a point, right? I have two choices, right? This is my array. So this is start, right? This is end. So either pick this one, two choices, right? We have two choices. If I pick start, right? If I pick start, then next player, right? Next player is left with these two one, right? Let's say x1, x2, x3, x4, right? Right? And if I pick end, the next player is left with what? x1, x2, x3, right? See, if it's turn, right? Player A turn, right? Player 1 turn, right? So what he wants, right? His score should be maximum, right? So what he will choose, right? This is, let's say if we choose left, this is say if we choose right, right? So his score should be maximum, right? So what he choose, right? Maximum of left comma right. Can I say right? Okay. If it's player 2 turn, right? Again, his score should be maximum, right? So what he chooses, right? Maximum of left comma right, right? Now, now let me ask you one simple question. So this is fine, right? So if you get this point, then you can simply solve, right? So you write a recursion basically, right? Recursion has your nums. Okay, you have your start, you have your end. Okay. See, base case is what? If start greater than end, is there any score you return? There is both score cannot have any score, right? Okay, now tell me, if I want to choose left, right? If I choose left, right, then what happens, right? The next, 1 second. So next will be right recursion of what? Now enums will be same. It goes standard plus one, start plus one, okay, and right equals to what? Recursion of what? Nums start and minus one, and also we need the turn here, right? Okay, whose turn this is? Not of turn. That is, we are going to reverse the turn. Okay. Now, if turn, right? That means player one is playing now, right? Player one is playing now. Okay. Now, what this my left and right contains? It contains two six, right? Two things, right? Player one score and player two score. Player two score. Okay. So we'll say this one A, this one B. Okay. Now, see if player one. Okay. So if we pick left, right, then what it becomes, right? See nums of start plus this left, right, this left, and its first, right, A part. If he picks right, what it becomes? Nums of end plus, right? He picks right, right, right. Now, which one he wants to pick, right? Whatever's maximum. See, greater than equals to. See, I'll also tell you a small approach after this, but this is the basic theory, right? both always plays optimally, right? So for player 2, you do similar, right? See, if then what happens, right? If pick left greater than equals to pick right, then our answer equals to what? Pick left, right, comma. What is the second one? If he picks the left, what is the score of second player, right? Left dot b. Else answer equals to what? Right? If he picks the right one, okay. What is the score of second player, right? Dot b. Similar you do a right, and in the end, whatever is used, you return your answer. So then at each point, right, at each stage, you have two choices, right? Your score of A, your score of B, basically. So this is one thing, right? So in the end, simply return, right? If, right, let's say you call your recursion, right? Recursion, you call nums, you call 0. What is this? N minus 1. Turn is 0, right? So let's say score, right? Final score. Then whatever you do, what you return, right? Return score of A greater than score of B. Now this is one thing. Now let me ask you one second question, right? Question 2. Can I write right net score at any point? Score of A minus score of B. Can I say this thing? No. If right player one turn, right, what he wants, right? This net score, right? Net score to be big and positive. See, because he wants to win, right? If he wants to win, this net score should go up, right? If it's player two's turn, right? Then what he wants, right? Net score to go come down, down and towards negative, right? See, if the second player wants to win, he wants one to drag down, right? So can I say it simply, right? At each point, right? At each point, maximum of left comma right, right? Whatever is maximum of comma left comma right, subtract it from score, net score basically. So can I write the same thing, right? If recursion start, okay, and now num see. Now we don't care about turn. Why? Because at each point we want this net score, right? Both players want to maximize their net score, right? Their net score. But player two wants to minimize, right? That entire net score basically. So say you will say, right? If start right greater than end, you return 0. Okay. Otherwise, see, left is what? Recursion of what? Start plus 1 and nums. Right is what? Recursion of start and minus 1 nums, right? Okay. Now, see, whoever's turn it is, right? Can I say to return whatever score we get? Let's say we get left, we get right. So what do you return basically? Now, maximum of what? See, if right, this is the left score, this is the score when they pick the right one. So what do you say, right? Say, right, nums of start minus left. If it's right one, what do you say? Nums of end minus right net score, right? See, net score you get when you pick left, net score when you get when you pick right. That is what you want to return, right? So you can also write this. This is simple basically. Now you can also memoize it, right? Because it all they depend upon start and end, right? So you can memoize it simply basically. Uh, okay, let's say here you do right. Let's see if you do memoization of start and not equals to minus 1. See, memoization is easy basically, right? Start and If it's not at the before when you return, you do right memoization. You save this result equals to this one. Okay, this is only memoization only need 2-3 lines of code change. Similarly, if you want to do memoization in this one, see this one also it depends upon start and end, right? At any point the answer depends upon start and end. So you can do the similar thing here, right? Memoization of start and not equals to -1. What you do, you return, right? Memoization of start and in the end what do? You okay, you write it like memoization of start and equals to answer. Okay. Then it becomes DP approach is worse than off and close. And basically otherwise the time complexity what? Of to raise to power n. This is recursion time complexity. This is DP memoization time complexity. Okay, got it? Yeah. Okay, let's see the code part quickly. Okay, let's quickly see the code part. Oh, I solved it before when? Okay, I solved it 3 years ago, July 20. Today's August 2026. Okay, let's see. Later we'll compare what I solved when I was no. Okay, we already seen right what we want. We will solve it via net score basically, right? Okay. So what I'm going to do here, return what? Mm, right, if net score basically, right? Net score greater than 0. Net score of what? Nums 0. End is what, right? So let's say if I do int n equals to what? Right, nums dot len. So I'll do right n minus 1 basically, right? Okay. Then we do private int net score. Wrong. Antinum start position, anti end position, right? So if start greater than n, this is the base case, right? We return 0. Otherwise, not right. Pick left. If we pick left, right? If the current player picks the left, right? What do we do? See, and the left equals to what? Nums of start, right? Minus. See, if I pick the left, what is the best score of the next player, right? Next player is what? Num start plus 1 and right. What is the best that the next player can get? Similarly, and pick right, right? And the right equals to right. Nums of what? And minus again the best score, right? That the next can get start and minus 1. Return what? Math, right? And at any player, right? They want their maximum. Does this make sense? Don't know. I think it's correct only. Okay, this should be greater than equals to 0. Because if it's positive, right, then if it's positive or same, then player 1 is winning, right? Okay. See, anyways, I think we'll get TLE or something, but since it's 20, maybe it will work. Okay, it's working. But let's memoize it, right? This is not optimal. Which, right? We can use a DP, right? Integer. Can I say memo, right? Okay, let's say memo equals to what? New integer, and what is the length, right? dpn, we'll say n. Okay, see, this is present, right? uh, if this is present means what? Memo for start, and if it is not equals to null, right, then return what? Memo start, right? and in the end we save it. If it's not present, right, it's positive. It did max score of was difference, right? The net difference should be positive, right? If player one wins. Okay. This was basically we did, right? Score, you see this thing, right? It's two times score greater than equals to sum. So in this case, the net difference will always be positive. That's why it's very complicated. I was noob back then. It's fine. I think now it's much better. See, now my code is very clean and better. Thank you.